In the previous video, we learned that water sometimes reacts with itself. We call this autoionization and forms a very little bit of hydronium and hydroxide. We also learned that the concentration of hydroxide times the concentration of hydronium in any solution is 10 to the minus 14. When we multiply those together, we call this Kw. It's a constant. In this video, we're going to learn about pH. So, if I put hydrochloric acid into water, it ionizes 100%. What if on the bottle it says 0.01 molar hydrochloric acid? Is there really any hydrochloric acid in the bottle? Well, actually, it has all become hydronium. That's because it ionizes 100%. Water doesn't ionize 100%. Weak acids don't ionize 100%. But strong acids like HCl ionize 100%. So in reality, in this solution, the concentration of hydronium equals 0.01 molar. That, again, because all the HCl has reacted. There's none left. So we say that the concentration is 10 to the minus 2 molar. And that's the concentration of hydronium. Well, we have a nice little way of writing this out. We have what is called pH. It's just a shortcut little way of expressing 10 to the minus 2 with a larger number. So pH equals the negative log, which I will review in a second, of the hydronium concentration. What's negative log? The log of hydronium concentration, in this case, is this number right here, the power of 10. So the log equals minus 2. Chemists just thought it would be nice to have a positive number. So pH, as I said, equals the negative log of the hydronium concentration, which in this case is going to equal 2. So simply, we're changing that number, taking that number as an exponent and making it positive. In the previous video, we saw that the hydronium concentration times the hydroxide concentration always equals 10 to the minus 14. That being the case, if the hydronium is 10 to the minus 2, what would the hydroxide be? It would be 10 to the minus 12. So the POH equals the negative log of the hydroxide concentration. It's figured out the same way, which in this case would be 12. So you can see where that number comes from. You might also notice that the pH plus the POH always equals 14. You can see where that comes from. So that would always be the negative log of 10 to the minus 14, which is the negative log of Kw. So we've heard that, maybe you've heard that the pH of certain solutions are neutral or acidic or basic. How does that work? Well, first of all, I want to explain that a pH of 2 is not twice as acidic as 1. Definitely not. A pH of 2 means 10 to the minus 2 molar hydronium. So what that means is that the hydronium is 0.01. A pH of 1 means 10 to the minus 1 molar hydronium. That equals 0.1 molar. So you can see the lower the pH, the more acidic the solution. And you can see that this is 10 times more acidic. So it's a logarithmic scale. So I just want to show you the pH scale. You'll notice here that as the hydronium increases, so here hydronium is increasing. And going down, we can see that the hydroxide is increasing, going down. We can see right here in the middle (10 to the minus 7, 10 to the minus 7, pH of 7). We can see that hydroxide at this point equals hydronium. That's what we call neutral. That's the way it is in pure water. But you'll notice above (10 to the minus 7), you can see that all of these, in all of them, you can see that the hydronium is greater than the hydroxide. So these are all acidic. A pH less than a 7 is acidic. What you need to know, though, is a pH of 5 is 10 times more acidic than a pH of 6. A pH of 4 is 100 times more acidic than 6. A pH of 3 is 1,000 times, and so it's a logarithmic scale. Conversely, below this line, These are all basic solutions. Basic means you have a pH greater than 7. And again, pH less than 7 is acidic. All right, let's give it a try. Is a solution with a hydronium concentration that is 2.0 times 10 to the minus 10 molar. Is it acidic, basic, or neutral? Remember, we could also use hydrogen for hydronium. Well, all you got to do is look at this right here. Here's the hydronium concentration, 10 to the minus 10, and you see that it is basic. So the pH scale is very useful for us in very quickly determining how acidic, how basic, or if the solution is neutral.